Oh, my word. Welcome and hello. It is Friday. It is May 15th, and we are gathered here today to be able to name alkane chains. That's what we're going to do. This is our second day in this organic chem unit, and I am going to try to move at a pace here so that we don't take too long on this. So, alkanes. Alkanes are carbon chains without double or triple bonds. So they will not have any sort of features in them, and they're very, very simple hydrocarbons. So let me get the pen out here from its dock. Oh, come on. Ha, done. Now, methane. Notice that all of these things end in ane. All of our alkanes will end in this A-N-E ending. That means it's an alkane. Everything we're going to do here ends in ane. Methane would be a single carbon. Meth being that prefix that means one. Eth would be two carbons chained together. Prop means three carbons, and they would be chained together. Butane, four carbons. And because these chains tend to have a bit of a seesaw effect in real life, that's why we usually draw them that way. Pentane here will be five carbons, 1, 2, 3, 4, 5. Now, you're saying, hey, Mr. Winstanley, where are all the hydrogens? The hydrogens here are effectively assumed, so we're not going to draw them on. Methane here would be CH4, ethane here would be C2H6, and propane C3H8, and on, all agreeing to that formula for alkanes CXH2X plus 2, the alkane naming formula. Hexane, hex means six, so this would be 1, 2, 3, 4, 5, and then 6. And you're probably saying to yourself, that looks a little boring. So heptane, which means 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Every bend and the ends of the line each represent a carbon. So we can represent these carbon chains very, very quickly. Octane, I want 8. So 1, 2, 3, 4, 5, 6, 7, 8. And it is one longer than that. Non-ane would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then decane would be longer than that. So this has also served as a bit of a redo of your prefixes that we're going to be using in here. Just to go back, remember meth, eth, prop, and butane, monkeys eat peeled bananas. Those are the only ones that are different from the traditional ones that we use. Okay, here's your rules, and Lordy, look at this. Okay, naming branched alkanes. IUPAC is the International Union of Physical and Applied Chemists, and they have agreed upon this naming so that everybody calls things by the same name. Now, these rules, and I copied them into your assignment for today. You want the longest continuous carbon chain, and that will be called the parent chain, and that is the longest chain that we have. Here, it's 8 carbons long, starting here, and it runs all the way to here. You then number everything from 1 to 8. You start with the closest branches. So you would want to start making this one number 1 rather than number 8. You would want to start at this end because it will give your branches shorter numbers, smaller numbers. So you always start with the ending with the first branch, the one that branches out first. Now, identify the substituents and give each a number that the carbon is connected to. So this is connected to number 3. So that is 3, and it's a single carbon, so it's 3-methyl. Here on number 5, we also have a single carbon, or methyl. And here on 1, 2, 3, 4, we have a 2-carbon group, 1 and then 2. So that's an ethyl group. We list the substituents alphabetically before the root name. We don't look at prefixes, but we alphabetize them. So ethyl always comes first because it starts with E, and that's a lie. Butyl comes first, then ethyl, MNOP, then methyl. Yes, I really did that. And then prop will be last. punctuation, commas separate numbers from each other, and hyphens separate numbers from names. And then we try to use as few spaces as possible. 4-ethyl, 3,5-dimethyl, octane because it's 8 carbons long. Okay, raced through that, but I think an explanation here. Let's take a look at some examples. This is a little less hyper and a little more easy to see. So this is 2-methylpentane. Why is it pentane? Because it's 1, 2, 3, 4, 5. So it's pentane. The methyl group is on the second carbon, so it is 2-methylpentane. Single carbon here, so this is a methyl group. A single carbon is a methyl group. Why did we start at this end? We wouldn't want to start at this end because then it would be 4-methylpentane. You want the shortest numbers possible. This is 3-ethylhexane. And again, we're going to be numbering from right to left rather than left to right because it's shorter. So it's 1, 2, 3, 4, 5, 6 carbons in the main longest chain. So that makes it hexane. And this 2-carbon group that's off here, 2-carbon is ethyl. So it is a 3-ethylhexane. Because it's on the third carbon, it is 3-ethylhexane. Here, our longest chain runs 1, 2, 3, and then 4. That makes it butane. Both of the branches come off the same carbon, which is the second one. So it is 2, 2, because they both come off the second carbon. Dimethylbutane, di meaning 2 methyls, dimethylbutane. This one down here is 2,3-dimethylbutane. So again, if we go across, here's our 4 carbons. That makes it butane. So that's the ending. 2,3-dimethyl, the second and third carbon contain a methyl group. This on the second and this one on the third. And by the way, this one is interesting because you can look at it a couple different ways, and it will always come out as 2,3-dimethylbutane. If you were to start at this end and count back, it still works the same because of the symmetry of this thing. Okay, there's 4 examples for you. Let's do some that aren't labeled up. So here I have an example. The longest chain I already have marked out, and it's 8 carbons long. So that means this is going to be octane because it's 8 carbons long. Then I take a look at my groups here. This is a 2-carbon group. So this is ethyl. This and this are single carbon groups. So they are methyl groups. Single carbon branches. So I need to say that this is 3-ethyl. Comma. I'm not going to leave myself enough room. And then the methyls are on 4 and 5. So it's 3-ethyl, 4, 5, dimethyl octane. So our final name there, I'm going to slide over here, is 3-ethyl 4, 5. I usually put a comma in there too. I don't know if you're supposed to, but it makes it easier to see. Dimethyl, because there's 2 methyl groups, octane. Key thing to do, find the longest chain first. Then look at your branches. What are they? And then make sure you're starting from the shortest end so that you end up with the shortest numbers. Here in this example, if we were to count, and let's just take a look at this. If we were to start at this as being the first carbon, then our chains, or I'm sorry, our branches off the chain would be at 1, 2, 3, 4, 5, and 6. Now, 4, 5, and 6. Here we have 3, 4, 5. If we add these 3 numbers up, 3 plus 4 plus 5, that equals 12. We add these up, 4 plus 5 plus 6 equals, I'm thinking that's 15. Your branches will always add up to the shortest totaling of the numbers. Okay, now, here we go. We've got 1, 2, 3, 4, 5. So 6, 7, 8. So this is also an octane. And a matter of fact, it is the exact same thing, even though we've drawn it slightly differently. On the third carbon, we have these two. So this will be 3-ethyl. On the 4 and the 5 here, we have the two methyls. So 4, 5 dimethyl. And these two words should be connected, but my handwriting's crappy on the computer. And that's how we're going to be doing these. When you're naming your branches, you want to come up with the lowest numbers possible. So let's look at this thing here. First of all, learn to ignore all the hydrogens because they're not really playing any role in this. And I'll put myself down here. So what is my longest chain here? I'm going to start and go 1, 2, 3, 4, 5, 6, 7. And it wouldn't matter whether I went up or down. 8. So I'm thinking that 8 is the longest I can do. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Still not good enough. So this is going to be my chain. Now, which end do I want to start with? All right. If I start at this end, and I'm going to have a methyl group here. This here is connected to the middle carbon. This is a bit different. This is a propyl group, and this will be, this is actually isopropyl, but into the Y of it in a second. And then here I've got 1, 2 on the end here. This is an ethyl group. Okay. Now, where do I want to start counting this? 1, 2, 3, 4, 5, 6, 7. So 4, 5, and 7 would be 16. Or if I start counting at this end, it'll be 2. And I want to change colors on this. I hope this video isn't going too long. I have to edit things out if it is. Where the heck are my colors? Where are you hiding? Oh, there you are. All right. So 1, 2, 3, 4, 5, 6, 7, and 8. And all I've done is count backwards. So now I'm at 2. If I'm in blue here, I'm at 2, 4, and 5. And that'll add up to 11. So that tells me that I'm going to be counting from right to left this time using the blue numbers. So key important thing here, this is octane because it's 8 carbons long. The longest chain is 8 carbons long. Now, the first thing I want to name is the ethyl group because it comes first in the alphabet. So it is on the 5th carbon. So it will be 5-ethyl. Comma. Next, the I does count. So this is isopropyl. So this will be 4 isopropyl, comma, 2 methyl octane. 5 ethyl, 4 isopropyl, 2 methyl octane. That is how it is done.